Hello viewers, welcome back to my channel. This is Dr. DORCAS NGIGI. We are moving on with our topic of the third topic now of uniform circular motion. Now in the first lesson, we looked at angular displacement, okay, which we said is a radian, which we said the angular displacement is given in radians. We also looked at, in our second lesson, we looked at angular velocity, omega, which we said is also given in radians per second. We said angular displacement is given in radians and angular velocity is given in radians per second. So it's a measure of how many angles a body is covering in 1 second. Angular velocity is a measure of how many radians a body is covering in 1 second as it goes around the circle. Okay, so today we're going to go right away to examples. So we are going to look at different examples, like 3 examples, where we shall calculate angular velocity and probably angular displacement, frequency, period, all those stuff. And that way we're going to understand those terms better. Okay, so I welcome you so that we move on together. Okay, so we're going to look at examples. So number 1, let's do the first one. A turntable and turntable rotates at a rate of 45 revolutions per minute, full stop. What is its angular velocity in radians per second? Okay, that's our first example. So we're going to work out this together. So we have a turntable, of course it's circular. Okay, is rotating at a rate of 45 revolutions per minute. Okay, 45 revolutions per minute. What is its angular velocity in radians per second? Now, angular velocity, we said, is given omega. Is what we call angular velocity. We said it's given in radians per second. Okay, so angular velocity is given in radians per second. So how do we calculate angular velocity? Now, we said 1 revolution, if you start here, go round all the way back to that point, that is 1 revolution, you will have covered 2 pi radians. I hope you remember that. Why? Because we say 1 revolution is equal to 1 circumference. And 1 circumference we said is 2 pi r. But also remember that 1 r subtends 1 radian, because we say an arc length equal to the radius subtends a radian, an angle equal to 1 radian. So 2 pi r, in terms of r is a radius, is equivalent to 2 pi radians in terms of angles. So 1 revolution is 2 pi radians. Okay? But this body is making 45 revolutions. The 1 revolution is 2 pi radians. So what about 45 revolutions? Okay? So I have to cross multiply. So that will give me 45 revolutions times 2 pi radians divided by 1 revolution. So of course revolution and revolution will cancel. 45 times 2, those are 90. So this is equivalent to 90 pi radians. Okay, so 45 revolutions equals to 90 pi radians. Okay, but those 95 revolutions are in 1 minute. So it is covering I bring that here. It's covering 45 revolutions in 1 minute. Per minute, in 1 minute. And 45 revolutions are how many radians? They are 90 pi radians. Okay? In how long? In 1 minute, and we know 1 minute is 60 seconds. Okay? So in 60 seconds, it is covering 90 pi radians. So what about in 1 second? We simply cross multiply. So it is 90 pi radians times 1 second divided by 60 seconds. Okay? Cos second and second cancel. The back of this, there is 0 and 0. By 3, 2, by 3, 3. That's all. By 3, 2, by 2, 1, by 2, 1.5. So it is covering 1.5 pi radians in 1 second. So it's covering 1.5 pi radians per second. And that's omega. Okay? So we have given omega in pi radians per second. So if you want, you can convert this pi. You can decide to use, let's say, pi equals to 3.142. So you can multiply this pi. Instead of pi, you simply put 3.142. So that gives you 1.5 times 3.142 radians per second. So I can say omega equals to, if I work out that, it's 1.5 times 3.142, that's 4.713 radians per second. Okay, that's our answer. That's the angular velocity. Now let's go back. So we have said what? One, we have angular velocity, angular, meaning from the word angle. So angular velocity. So the fact that it is a velocity means it is per second. Angular meaning it is given in those angles per second, so it is radians per second. Now very easy. 1 revolution is 2 pi radians, because a whole circumference 360 degrees is subtended by a whole circumference, and a whole circumference is 2 pi r, 2 pi radiuses, and each radius subtends a radian, so means a whole circumference is 2 pi radians. But we are not talking about 1 revolution, we are dealing with the 45 revolutions. So if 1 revolution is 2 pi radians, 45 revolutions will be equal to 90 pi radians. Okay? But those 45 revolutions are in 1 minute. So we want to know how many revolutions in 1 second. So 45 revolutions, that is 90 pi radians, but per minute. So the 90 pi radians are in 60 seconds, that's 1 minute. What about in 1 second? So I just cross multiply. And what do I get? In terms of pi, omega, angular velocity, will be 1.5 pi radians per second. If I don't want to give my answer in terms of pi, then I can substitute that pi with 3.142 or 22 over 7. So I'll get 1.5 times 3.142 radians per second. And that is our angular velocity. Okay? Now we can take example 2. So we have a model car moves round a circular track. Of radius 0.4 meters. At 2 revolutions per second. Okay, what is its Roman 1 period, Roman 2 angular, velocity omega, and Roman 3 linear velocity v. Okay, now that's the question we have. We have a car that is moving around a circular track of radius. So let me use the same circle for question 2, radius 0.4 meters. And it is going around at 2 revolutions per second. So in 1 second, it is making 2 revolutions. So question number 1, what is its period? Now, what is period? Period, when you look at it in terms of circular motion, we are looking at the time taken by an object or a body to go around 1 revolution. We talk about period when we're talking about waves, and we define period as time taken to cover a distance of 1 wavelength. Now, 1 wavelength in a circular motion is 1 revolution. So we talk about period, that is the time taken to go round 1 revolution. Now that makes it very easy. So Roman 1, we are saying it is making 2 revolutions in 1 second. Per second, I mean. It is making 2 revolutions in 1 second. And we are defining period as time taken to cover 1 revolution. Okay? So if 2 revolution is 1 second, what about 1 revolution? We simply cross multiply. So that becomes 1 revolution times 1 second over 2 revolutions. Revolution and revolution cancel. So 1 divided by 2, that is 0.5 seconds. Okay, so Roman 1 equals to 0.5 seconds. To answer that. So period is time taken to go round 1 revolution. That time taken is what we call period. Roman 2, angular velocity omega. So angular velocity omega is, we have said, is given in radians per second. Radians per second. So Roman 2, it is taking 2 revolutions in 1 second. 2 revolutions. And we know 1 revolution is 2 pi radians. Okay? So what about 2 revolutions? It is 2 revolution will be equal to 4 pi radians. I'm simply taking cross multiplication. 2 revolutions times 2 pi radians over 1 revolution, which is 4 pi radians. And we are told angular velocity, that is in radians per second. So what are we saying? So it is 2 revolutions in 1 second. 2 revolutions in 1 second. And 2 revolutions are 4 pi radians. So is equals to 4 pi radians per second. If you don't want to give it in terms of pi, then you can change that pi 4 times 3.142 radians per second. So that gives us what? It's 4 times 3.142. That's equals to, so omega equals to 12.568 radians per second. So I can say this is 12.568 radians per second. Okay? So that's the angular velocity. So very simple. So just know 1 revolution is 2 pi radians. So 2 revolutions will be how many radians? Because it's 4 pi radians. If you don't put it in terms of pi, you substitute pi with 3.142 or simply 22 over 7. And then you get in radians per second where there is no pi. So angular velocity is 12.568 radians per second. So we have answered the 2 parts of the question. Finally, linear velocity. Now, when you talk about linear velocity, one circumference is 2 pi r. One revolution is 2 pi r. That's the circumference. So 2 revolutions are how many? So 1 revolution is 2 pi r. So 2 revolutions will be equal to 4 pi r. So 4 pi r. And what is r? Remember, is per second. So 4 pi r per second. So linear velocity v is equals to 4 pi r per second. But we don't want to put in terms of r because r has a value. So it is 4 times 3.142, that's pi, times r. What is r? 0.4 meters. 0.4 meters per second. So we work out everything. Remember we said angular velocity, linear velocity is omega r, but I'm not going to use the formula just so that you can follow what I'm doing. So we are saying is 4 times 3.142 times 0.4 times 0.4. That gives us 5.0272 meters per second. So very easy. So linear velocity equals to 5.0272 meters per second. Okay, so we've just converted. Remember, angular velocity is in radians per second, but linear velocity is in meters per second. And it's very easy. One circumference is 2 pi r, where r this time is not radian, is radius. 2 pi r. So 2 revolutions are 4 pi r. But remember, there are 2 revolutions per second. So it's 4 pi r per second. So I'm simply substituting pi for 3.142 and r for 0.4 because that is the radius of the circle. And then I get my answer in meters per second because r is in meters. Radius is in meters. Okay. So last example. Hope you have understood the 2 examples. I don't want to wrap them, but I have nowhere to write. So I just have to wrap this. So example 3. Find the angular velocity and frequency of the motion of the car if it moves with a uniform speed of 2 meters per second in a circle of radius 0.2 meters. So you're told to take pi equals to 3.142. Okay. Now let's go through the question together. So we're told we have find the angular velocity, of course omega, and frequency of motion of the car if it moves with a uniform speed of 2 meters per second in a circle of radius 0.2 meters and take pi as 3.142. Now what we have here, we have v, linear velocity, 2 meters per second. Remember, linear velocity is in meters per second. So it is going around a circular path. Let's go back, that's our body. It is going around the circular path, covering in every 1 second, it is covering a length of 2 meters. After every 1 second, it is covering a length of 2 meters. So the question is, these 2 meters that it is covering in 1 second are how many radians? What angle does is subtended by the 2 meters? How many radians are this? Okay, we know that to subtend 1 radian, the length here should be equal to the radius, so it should be equal to 0.2 meters. The radius of the circle is 0.2 meters. So to subtend 1 radian, the length here should be equal to 0.2 meters subtends a radian. So this length of 2 meters will subtend how many radians at the center? So to know that, I must divide by r. So V over r, where r is 0.2 meters. Okay, why? Because 0.2 meters subtends 1 radian. Every length of 0.2 meters, that is equal to the radius, subtends a radian. So the 2 meters in 1 second, remember, the 2 meters are how many radians? To know that, I must divide by 0.2 meters, because every 0.2 meters subtends a radian. So to know how many radians, I must divide by 0.2 meters. I hope you follow that. So that gives us times 10 times 10, that's 20 over 2. That's 10. Okay, so 10 radians per second. Okay, so because this is 0.2 radians, so every radius subtends a radian. So if I divide by 0.2, which is equal to length over radius, then I get the number of radians subtended by a length of 2 meters. So those are how many radians? 10 radians per second. So omega, of course, which is V over r, is 10 radians per second. I hope you're able to follow that. So we have answered the first part. Find the angular velocity. We have answered that. And frequency. Now, what is frequency? Frequency is a measure of how many revolutions in 1 second. In terms of waves, you look at frequency in terms of wavelengths per second. In terms of circular motion, we'll be looking at frequency in terms of revolutions per second. It's like we are talking about here, 2 revolutions per second, that is frequency. So in our case here, how many revolutions per second? Now we know one revolution is 2 pi radians. Okay, one revolution is 2 pi radians. Now in terms of without pi is 2 times 3.142 radians. So is equals to multiplied by 2, that's 482.6 radians. That's one revolution. But the angular velocity is 10 radians in 1 second. 10 radians. Remember, frequency is per second. So how many revolutions in 1 second? Now we need to know in 1 second, how many radians is it covering from our angular velocity? So there are 10 radians in 1 second. So if one revolution is 6.284 radians, what about 10 radians? How many revolutions are those? Then we cross multiply. So 10 radians times 1 revolution divided by 6.284 radians gives us the number of revolutions in 1 second. Why? Because the 10 radians are in 1 second. So we have 10 divided by 6.284. So this is equals to, so frequency will be equal to 1.59134 revolutions per second. Okay. So we have answered the 2 parts of that question. We have answered the angular velocity, which is given in radians per second, and we have answered the frequencies. Frequency is a measure of how many revolutions in 1 second. So if you know the number of radians per second, then you can convert those radians per second to revolutions per second. How? One revolution is 2 pi radians, which is equivalent to 6.284 radians. That's one revolution. So 10 radians, because there are 10 radians in 1 second, so 10 radians are how many revolutions? then it's 1.59134 revolutions. But remember, it is per second, so per second, and that becomes our frequency. Okay, viewer, that brings us to the end of our lesson. I hope you enjoyed the lesson. You have followed it to the end. I've given 3 examples. I hope you'll be able to follow them. Until next lesson, goodbye.